I am Bert Beckwith, and technically I work for Pivotal, but used to be VMware and still Spring Source, and really I just work for Grails. I work for you guys. So, all right, so transactions in Grails. So we first just database level, but just as an application developer, as a Java/Groovy JVM developer using JDBC with some wrappers around it. A transaction is basically, mechanically, you're going to get a connection, you set auto-commit false. The default is true, so every statement you normally make is going to go right to the database. And that way you can do multiple things, and then if something goes wrong, you can either choose not to commit or explicitly roll it back. It's basically that, and then assuming everything goes well, then you do commit. And of course there's a whole bunch of error handling and try catch and, but assuming that everything's going to work, it's pretty simple. Get a connection, don't auto-commit anything, push it when you're ready. All right, so that's not so bad. Now before we talk about transactions in Grails, we have to talk about ACID. ACID is an acronym, right? So it's atomicity, consistency, isolation, and durability. So atomicity is really, I think, what we all tend to think of when we think of transactions. It's the all or nothing thing. So you do, a couple inserts and some deletes, and either they all happen, they all succeed, or they all fail. So it's an atomic work group. Consistency is making sure that the database is consistent after the transaction, so there's no foreign key violations. Once you do your work, things make sense again. Isolation refers to the idea, and I'll talk a lot more about this later, of how much can other transactions see of the current transaction that you're doing, either none or some, or because there's different performance concerns for different isolation levels. And then durability is a really important thing too. If you get the message back from the API that says that the commit succeeded, but then the database crashes, server crashes, power goes out, whatever, the database, in order to be compliant, ACID compliant, has to write the information to log files so that if in the event of a failure like that, it can replay the transaction when the system comes back up again and make sure everything works. So those four things together are really important to have a robust transaction support in the database. So that's the sort of a general theory about transactions in general, but how do we use them in Grails? It's really easy. There's two main ways. There's transactional services. That's the easiest way. And then there's the more fine-grained approach of using the @transactional annotation. And then as of, 48 hours ago, there's a new third way that I just had to add to my slides. Thank you, Graham. Where at the HackerGarten, Graham and a few other folks came up with an AST transformation that will do the same work that the Spring transactional annotation does, but without having to create a runtime proxy. So it actually reworks the code so it wraps each method call inside of a transactional wrapper within, like a mini proxy within every method, but the whole class doesn't have to get proxied. So we're thinking about using that for Hibernate, and also there are proxies in the caching plugins and also in Spring Security. So I would think that this will be a pretty cool approach. So how do we have a transactional service in Grails? It's as simple as create service name. So if I say Grails create service it's going to create a class called the service, and it's empty. Actually, I think we create a dummy method in there, right? Do something or whatever. But it doesn't say anything about transactionality. It doesn't say static transactional equals true. It used to, but we removed that because it was redundant. We always defaulted to true. So this class by itself at runtime is going to be wrapped in a Spring transaction proxy. And what's going to happen then is every method call is going to get intercepted. And depending on whatever rules you've configured for that particular method, and we'll talk about that in a bit. It will either start a transaction or join a transaction or start a new transaction or throw an exception because the transaction isn't allowed, or whatever rules are defined for that method. It's going to do that work for you. So you don't clutter your code with a bunch of stuff at the top and a bunch of stuff at the bottom and a big try catch and all this. And you end up with a nice clean separation of concerns. So that's great. But every method has the same transaction semantics. You can't say that any method isn't transactional. You can't customize anything. It's really all or nothing. You get the default behavior, and you can't do anything else. So if you want a more fine-grained approach, you can use the @transactional annotation. So it turns out that if you have a single annotation in the class, you want to think of transactional. There's an implicit static transactional equals true. Think of that as auto-transactional. So without doing any work, it's automatically going to be wrapped in a transaction using all the defaults. If there's any annotations at all at the class level or on any methods, then the auto-transactionality is turned off. So you don't have to add the annotations and then say static transactional equals false or anything like that. You don't get a mix of behaviors. You get one or the other. But in both cases, there's still going to be a proxy. It's just going to be configured differently. So these are all the attributes that you can have in the annotation. And let me talk about those in groups. So like I said, isolation is an important one. So that's an enum. The default is isolation default. I'll explain what that means in a minute. So there are 5 values for this enum. And remember that isolation is visibility. So how much can other transactions see of what is going on in this current transaction? So if you're at read uncommitted, what that means is that other transactions can see stuff that is, so you do 5 inserts, right? And at the 3rd insert, other transactions can see that insert value. When they do a select, they'll see that record. If you do an update, they'll see the new value. The problem with that, though, is that if you roll back that transaction after a value is read, you're going to get a dirty read, because the value that was temporarily set, or the row that was temporarily there, won't be there when the transaction rolls back. So this is very lightweight. This is the least expensive way of doing things, because there's not a lot of machinery in place at the database level for locking and control and everything. But there's that risk of concurrent reads are going to see different data. So it's rare that you want to use this setting because there's that relatively high risk of seeing bad data. So the next level up is read committed. And this is actually a default for most databases, many databases. Oracle uses that as its default. What that says is that if you commit, then other transactions can see that data. But you then have problems with repeatable reads and what are called phantom reads. So a next level up is repeatable read, which guarantees that if you read a record twice in the same transaction, you're going to get the same value twice because of read locking. And then the highest level is serializable, really, really expensive. That's going to block reads from you. So if you have a row lock for update and you're updating a record, no other transaction can even read that row. You can't read the safe value. It can't read anything. It's going to get blocked. So it's the safest approach. Everything's guaranteed to be perfect. You're always going to see the right data, but it's really expensive because your reads are going to. You expect that your writes are going to be slowed down by transactions. That's the cost of doing things the right way. But your reads are going to get slowed down also. So it's very rare that you would use serializable. And then there's a default setting which basically says, do whatever the database normally does if I don't say anything at all. So, and that's different for different databases. So for example, MySQL uses as its default repeatable read, whereas Oracle uses read committed, and a lot of others use read committed. So you can either leave it at the default, or you can say, I always want to use repeatable read, or I always want to use read committed, even in MySQL. So I have a demo of reading data wrong, and I'm assuming I'm going to go over, so I'm going to push that demo to the end, and I'll do a blog post where you can take the code and see that, because I don't want to run out of time. So let's talk about propagation. And I didn't say this up front, but if anything isn't clear, we'll have time at the end for questions, but please ask, please interrupt if anything doesn't make sense. So propagation, so what that means is what rules are in effect for when you enter a method, right? Every method is proxied, it's wrapped. So the default value is required. And if you've used, and I hope you haven't had to, but if you've used EJBs in J2EE, these map to the same concepts in EJBs for the J2EE spec. So required says that if there isn't a transaction running, it will start one for you. If there is one running, you'll join it. So that's pretty cool. Supports is a little bit weaker. That says if there's one running, I'll join it. But if there isn't one, don't start one. Mandatory says that you have to have a transaction running before you even call this method. And if there isn't one running, it'll throw an exception. So you have to either call it from another method that started a transaction or explicitly start the transaction yourself. Requires new is actually going to start a whole new transaction, not necessarily suspend the current one, but it's going to give you a second transaction. And one use case for that is you're doing some real work, right? Some business work. You do some inserts, updates, deletes, whatever. And then maybe you want to write some logging information to the database. If that fails, it's bad, but you don't want the failure of the logging information to take down the other real work that you did. If that would have succeeded by itself, but only the sort of secondary, not so important process fails, then you'd want that second new transaction to roll back by itself. Then you log that error, and then someone can manually fix that later on. So that's one use case. There's plenty of reasons why you would have requires new. But this says bounce out of the current transaction, do a new one, and then come back and join this up again. Not supported is sort of the opposite of mandatory. It'll throw an exception if there is a transaction running. No, that's never. Not supported. Right. You can look this up later. And then nested will create a nested transaction. So the ones you're going to typically see are required and requires new. Those are the ones I think most of the time. And supports maybe if you don't really need a transaction, but you can join one. So that makes sense. So the default for if you just say @transactional or if you just have a transactional service is required. So every method will start a transaction if there isn't one running. So, and then to kind of close that loop, if it started the transaction for that method, then it will commit it at the end or roll it back if it failed. But if there were already a transaction running, since it allows you to join that one, it's not going to commit the transaction because whoever started the transaction on the outside will have the responsibility of committing it. So it does the right thing. Okay, so this is kind of a weird thing. It's complicated by the fact that we're using Groovy and the fact that Groovy doesn't force you to catch checked exceptions. So the logic behind automatically rolling back a transaction because of an exception is this. If there's a runtime exception or an error, any sort of an unchecked exception, the assumption is that you didn't know about it. It happened and it escaped the method. So whoever, the transaction manager is going to automatically roll back that transaction because you probably weren't in a position to retry or do some logic or whatever. On the other hand, if a checked exception is thrown from a method, either because you explicitly throw it or you put it in the throws clause and you just deduct it, it's assumed that because it's a checked exception that you had to do a try catch or you had to say it throws. So you have a chance to fix the problem and try again or do something. So that gets complicated in Grails and in Groovy because you don't have to have a try catch for a checked exception. So you can have that behavior where a checked exception escapes the method. And you would expect that since you didn't have to catch it, it should automatically roll back the transaction, and it will not. So we've had some discussions on the mailing list about should we in Grails sort of change the way that transactions work to sort of fit the Groovy model. I don't know, maybe it's because I'm kind of a recovering Java developer, but I don't like that. I want stuff to sort of work the standard way. I don't know, I go back and forth on it, and we certainly haven't decided it. So, having said all that, there are times when there are some runtime exceptions and unchecked exceptions that you don't want to automatically roll back a transaction. And there are times when a checked exception should automatically roll back a transaction. So there are ways to specify the class or the class names that use the non-standard behavior. So that's kind of convenient. And then the other values, the value, can be it's the name of the transaction manager, so you can define which transaction manager. If you have multiple data sources, you can say that this is transactional with this transaction manager versus the default one. You can set a timeout. So if a transaction takes too long, it'll throw an exception and it'll roll back the transaction because it took too long. And you can also have read-only transactions, which are a little bit rare. But that would, one use case for that might be that you're not going to do any updates in your method, but you want to be able to read uncommitted or committed data that's in the current transaction. So that's pretty rare. But there are some optimizations, especially for Hibernate, where it will it won't do some work that it would otherwise do, so it can be a little bit more performant. So some quick examples of how the annotations work. So if you have an annotation at the class scope, then every method gets that same behavior, unless you override it at the method level. So in this class, the sum method is transactional with the values for this annotation, which are propagation required, isolation default, not read-only, standard timeout, all that stuff. But this one has all the other inherited value, all the other values. It doesn't inherit anything from this, but it changes the propagation. On the other hand, this method, since there isn't a class scope annotation, these two methods are transactional at the level that you talk about, but this method isn't transactional at all. So that allows you to have a really fine-grained control over your transaction demarcation. So you can have a relatively large service where some of the methods don't do any database access, so they don't need to have a transaction. There is some cost there, right? You're going to open a connection, do some work, do some try-catch logic, and all that. And that's unnecessary if you're not going to be going to the database. So you could either use this approach, or you could split the service into two classes, right? You can have one that only does database stuff, and then one that is just helper methods. Yeah.
But why is some method not transactional? I mean, isn't it the default for a service to be transactional?
So as soon as there's a single annotation in the class, then the automatic transactionality isn't in effect. Right. So, and as I'm saying all this stuff about transactional, this is also true for, it'll be the same behavior for in 2.3 with Graham's new annotation. So it has all the same attributes, all the same behaviors, and it does really the same thing. So instead of importing org Spring Framework transaction annotation transactionally, you'll import Grails transactional, I think. I'm not sure of the package, but yeah. So all the same behavior applies. So one sort of caveat, one thing that's kind of interesting is, this is that scenario that I was talking about before. So you've got a regular method that's transactional using whatever semantics. And then it does some work, does some persistence work, does some inserts, deletes, updates, whatever. But then it calls this other method to register the auditing data, right, doing some logging. And this says, go ahead and start a new transaction because this isn't quite as important as this work. So if this fails, we want it to roll back its separate unit of work, but we don't want that to take out the whole thing. So we'll log that, and later on, someone can manually fix what happened. This will actually not start a new transaction because it's a direct method call. So this is a little bit subtle, but remember how things work, right? There's a proxy. So Spring is going to create a cglib dynamic subclass of your class. And that's the actual instance that you're going to get back. So you're going to be calling methods on the proxy. And then it's going to do the logic of, should I start a transaction? Should I join a transaction? Should I start a new one? Should I throw an exception because there isn't one running? All that stuff, right? So it does all that layer of checks, and then it calls your actual method. It calls the subclass method, your real method. But once you're inside the class, if you call a method, you're underneath the proxy now. So you're not calling a proxied method, you're calling the direct method. So what you have to do is you have to go back out again and come back in. So it's kind of ugly. But what you need to do is do the same work, but then in order to call this method, you can't call it directly. You have to go get the proxied class instance and then call the method on the proxy. So you go back out of the class and back in again. So that's kind of ugly. And so you can't say def foo service because that's circular. You can't depend on yourself. So you have to go to the application context and get the bean. So I talk about it in the book, a way to add in this method in the meta class. And actually, we might add this in 2.3. Just an automatic method called getMyProxy or something like that, where so you could have a property. GetMyProxy would work just like a property called MyProxy. So it would basically do this work for you automatically. But it's easy enough for you in the Bootstrap to add in that method called getMyProxy to every service class, so you can automatically do this. So you still have to remember to call directly, you have to remember to call through the proxy. But the work of getting the proxy is a lot easier. And I'm pretty sure, I haven't really thought this through yet, I have to test this, but I'm pretty sure that with the new AST approach, that because the way the methods work, this isn't an issue anymore. So that's, yeah. Right, so a direct method call is going to be proxied, because every method is proxied in sort of a mini proxy instead of one big one. So, and this is not just the case for transactional methods. This is the case for any time you have a dynamically created proxy in Spring. So this is true for the cache plugins. This is true for the ACL, Spring Security ACL plugin. When you have a service method that's going to do an ACL check. Anytime you have a proxy, you have to do this kludgy thing until we fix it all. So Spring has a bunch of really convenient utility methods and classes that help things out. So the core of the support for transactions in Spring is the Platform Transaction Manager interface. And there are many implementations of this. There's one for JDO, there's one for JPA, there's Hibernate 3 Transaction Manager. Now that Spring has support for Hibernate 4, there's a Hibernate 4 Transaction Manager. And actually Grails, we have a very small subclass of this. So, but for the most part, all the behavior is inside of the Hibernate Transaction Manager. So this does a nice bridge between the Spring stuff and then the Hibernate stuff. So in particular, one thing that it does is at the end, when you commit a transaction, it will flush the current session. And I'm going to talk a little bit about how Hibernate sort of confuses things a little bit. Not in a bad way, it's a confusion in our heads. The difference between committing and flushing, right? They're really orthogonal. So anyway, the primary methods, or actually the only methods, these are the only methods in the interface, are get transaction. So that it's really you can sort of read that as get or create transaction, because it'll either get the current one based on those, the values inside of the transaction definition class, or it'll create a new one based on that. And then you can call commit or rollback, right? And the nice thing is you can call this manually. I hope you never would, because it's a lot of work to kind of wire this up. But the proxy mechanism calls all this stuff for you. So it's going to have that try-catch, and at the end, if everything went well, it's going to call the commit on the transaction manager. It's going to have a reference to the transaction manager. And inside of the catch block, if something failed and it's a runtime exception, and it's not one that doesn't automatically roll it back, then it'll call a rollback for you, and you can always call it yourself. Another helper class that makes the magic happen is the transaction synchronization manager. So this uses thread locals to keep a current transaction information available. So That's kind of nice because you don't have to sort of pass around the transaction object, right? You don't have to think about transactionality. I mean, you have to think about it when you're writing your code and when you're designing stuff. But the actual code itself doesn't deal with, this method calls another method, so it needs to pass along the transaction context and any of that stuff. I mean, that's all handled for you because it's available for the current thread. So one implication of that is that if you start a new thread inside of a transaction, you're going to be outside of that transaction, and you're not going to have an active transaction anymore. So it's pretty rare that you would think to do that, but that would break. So this has methods for binding and unbinding and getting resources. And the two big uses for that are storing the current Hibernate session inside of a session holder keyed by the current session factory, and storing the current JDBC connection inside of a connection holder keyed by the data source. So you still need something to hook into the thread local, because you could have multiple transactions running for different session factories. And a session holder can hold multiple sessions if there's, if you started a new transaction on the same thread. But this is how you always know where to go to get the current state, the current. And then there's also the transaction aspect support. So that gives you yet another hook into what's going on. So it's going to give you this transaction status object. So I'm not sure if I listed these, but yeah, so it's got a method called isSynchronization get the current. It's got a method called setRollbackOnly, which is how you roll back transactions. So that sort of begs the question, is the best way to manually roll back a transaction to throw a runtime exception? You guys do that, right? Come on, you do that. You throw exceptions to roll back transactions. That's a really expensive way to do it. Exceptions are always expensive, especially in Groovy. You've seen stack traces in Groovy, right? And there's a whole lot of information that's got to get collected there just to throw it away because you only use this thing as a message to roll back a transaction. You didn't use it as information. So you're using a side effect of the fact that a runtime exception will do that for you. The real way you're supposed to roll back a transaction is get the current transaction status and call setRollbackOnly. And what that allows you to do is have some pretty fine-grained workflows where you've got a multi-step workflow, right? You've got this method calls this method, which calls this method, and then each one of them does different units of work within a bigger transaction workflow. And at any point, if something goes wrong, you can say setRollbackOnly, and then anything you do from now on isn't going to get committed. And you can also check to see, is it rollback only? Has someone called setRollbackOnly? And you can not do that work, because it's going to get thrown away anyway. So this can allow you to have a little bit more performant, large workflows if you use this information. So one of the things I'm not sure if I didn't show that here. In the book, I have a little block of code where you can wire into the meta class of all your services these methods. So you can show how to have an isTransactionActive, get the current transaction status, setRollbackOnly, and isRollbackOnly. And all that they do is they call these methods. So it's very easy, again, in the Bootstrap, to add in these magic methods. Because one of the things that's interesting is that there's another way to do transactions in Grails, right? You can use the withTransaction method, the static withTransaction method on a domain class. It's kind of cheesy. Because what you're going to use that for is you're going to use that to do a transaction inside of a controller or inside of somewhere where you really probably shouldn't be doing that sort of work, right? We really shouldn't be doing persistence work in controllers. Controllers should be dumb, lightweight routers. You get a request, you pull out the parameters, the query string, the post values, you call a helper to do the real work, business logic, and then you get that response back, and then you redirect or render, or you display the results. So the controller shouldn't be doing any real work. So you probably shouldn't be using with transaction. But one benefit that with transaction has over transactional service methods is that the parameter to that closure is the transaction status class. So you can very trivially roll back a transaction inside of with transaction by calling set rollback only on that object. But you don't have that available to you inside of a service. So now you do. So you have no reason to ever use with transaction on a domain class, because you're going to move all of your logic into your services, right? So I'm going to talk a little bit about that in a bit, because we actually sort of almost imply by creating bad scaffolding code that you should be doing that work in the controllers. We need to fix that. I need to fix that. It's on my to-do list for 2.3. Okay, and then one other helper class that's really kind of cool that we just added use of in Grails 2.3 is the lazy connection data source proxy. So now, you guys know that the data source is proxied right now in Grails 2. Well, now it's going to be proxied again. So it's actually three layers. So the current proxy around the data source is a transaction-aware data source proxy. So that's kind of handy because if you need to do some SQL query, for example, especially like in an Oracle environment where there's some stuff you can really only do in SQL that there isn't an analog for inside a GORM. Or if you just got you want to call a stored procedure, or you're just being lazy and you could do it in GORM, but you want to do it in SQL. You would want to have easy access to the current connection that Hibernate and GORM are using inside of your transaction. And there's a way to get that, but using the current proxy data source, it will look for an active, it'll look for the current Hibernate connection, and it'll give it to you. So if you get the data source and you say get connection, it won't give you a new connection. It'll give you the current one, if there is one. And if there isn't one used, then it'll give you a new one. So that's kind of cool. Like, really does what you want it to do. You can get access to the unproxied data source if you don't want that behavior. So now you've got another layer on top of that. So what this is helpful for is, remember a couple slides ago I had a service that had one method that wasn't transactional, right? So imagine forget about @transactional, just a regular Grails service, right? You don't do anything, you don't say anything about transactionality. So every method is automatically transactional. But if there are a couple methods in there, or many methods even, that you don't do any database work, you're still going to start a transaction, do all that machinery, do all the try-catch stuff, do your non-persistence business logic, and then shut down the transaction. So wouldn't it be nice if there were a way to sort of avoid that? So you have to get a connection because you have to call set rollback only. Remember what I was saying on one of those very first slides. Mechanically, the core of a transaction in JDBC is getting a connection and saying set autocommit false, so that you wait until you know you're ready to push everything, and then you push all the changes that you made. So you have to get that connection to say set rollback only. So there's a cost there. And so what this does, it's pretty slick. So what it does is it actually caches all those method calls. When you say set autocommit false, set read only true, set transactional isolation, all those methods, it stores those values. And then at some point, if you actually say get connection, because you're actually going to do real persistence work, then it's going to get that connection, and then it's going to call all those methods on that real connection using that cached information. But if you never need a connection, then it doesn't need to get one. It's pretty slick. I think it's actually been around for quite a while. We just discovered it recently, so a little slow in the uptake, I guess. So that's the default behavior in Grails 3 now. So it's kind of weird, but it doesn't really mean anything because you can still say def data source and you get that triple layer data source and everything just works. So, but it's kind of nice to know that you should go through and annotate your methods that are transactional as being transactional so that the ones that aren't annotated don't incur that cost. But this is going to sort of do that for you. It's going to kind of make those non-transactional methods kind of zero cost. It probably still is a little bit of cost there, but it's going to really greatly reduce that. All right, so two-phase commit is kind of a cool thing. And this was always kind of important, but it became a lot more important when we added support for multiple data sources. So originally, I wrote the data sources plugin, and then in Grails 2, we merged that into core, so now it's just a part of Grails. So if you do database writes, updates, deletes, inserts, whatever, on two different domain classes into two different data sources, and you don't have two-phase commit support, then only one of them is going to be properly rolled back. So I've got another demo of that I'm pretty sure I'm not going to have time for. We'll see. I'm actually running a little fast. So what happens is, so you've got a transactional service method, right? And it's got a transaction manager. But there's actually two transaction managers in the system. There's one for every data source. So if you've got n data sources, you've got n transaction managers. But only one transaction manager can ever be active at one time. So if you do two inserts in one method into two different data sources, only the one that is governed by that transaction manager is going to properly roll back if you throw an exception, or if you say roll back. So the other one is going to be in auto commit mode because there's no transaction manager. It's not acting inside of a transaction. It can't roll it back. It could be a different database. It might not even be the same. You might be in Oracle and MySQL. I mean, you might have two completely different boxes. So what you need to do is have two-phase commit. You need to use XA transactions. So what you really need is a transaction manager that has a transaction manager for each data source. So that's really messy, but it turns out that Atomicos, which is a open source, not open source, but free library, they have a paid version and then a free version. And it's one of the most robust ones out there, for the free ones anyway, and it's really high performance and very popular. So I wrote the Atomicos plugin when we did Grails 2, and it's kind of cool because it doesn't just support multiple data sources, multiple databases. It supports JMS and JDBC and any other XA compliant technology. So one thing I've seen is you do an insert or you do some work, and then you want to do some asynchronous processing. So you fire off a JMS message into a queue, and you send maybe the ID of the newly inserted record or some information about what happened, and then at some point in the future, someone's going to go grab that message and do some work asynchronously. So if you were in a complex workflow and you do the insert, you send the JMS message, you do some work, and then something explodes, something terrible happens, right? So you need to roll that back. Well, you wouldn't want that JMS message to have gone through. You don't want to do that processing because it's going to try to go retrieve a row that's not going to be there. So wouldn't it be nice if there were a way to sort of queue up that JMS message and only send it if you commit? And that's exactly what happens here. So if the transaction rolls back, all the database stuff gets pulled back, JMS message doesn't go through. But if everything works, then everything's good. So if the JMS message sending fails, that'll roll back your database. Everything is all kind of combined. It's all atomic, right? Everything works or everything fails. So I don't know. I'm not going to do the demo. I will do a blog post. I will give you the code. You can do it yourself. It'll be better that way anyway. But you know what I'm talking about, right? So this is nice because and I think the great thing about the Atomicos plugin is it's really Grailsy. It does almost everything for you. So I can show you the code. So here's how you configure it. So you've got a data source, and then you've got a second data source. So unfortunately, it's not very dry because there's no standard for XA properties. So, because it depends on the driver itself. So this is a regular H2 in-memory database. It's just, I'm doing that because it's convenient. And then I've got a second data source that uses local MySQL. So I tell it the dialect and the class name and all that stuff. But then I have to specify the XA data source. And it's pretty much always going to be a different driver than the regular one because there's so much more work that's got to be done there. And you've got to pass in the URL and the username and the password because it's going to, you can see that right here, that, all right, in this case it is actually the same, but it doesn't have to be. There's no spec for what the property names are. So you can't really know what they are. So you got to repeat everything. But that's all you got to do. You install the plugin, and then you set up the XA config, and then it automatically converts that data source, which is a Commons regular data source, to an Atomicos XA compliant wrapped data source that actually works together and has all that machinery around it. And then here's a third data source that isn't transactional. And then I've got 3 different Hibernate settings. So this is pretty standard stuff for multiple data sources, except that you've got the XA config. At the same time, in this sample app, I have JMS installed. So I set up some JMS queues in the connection factory, but it's an XA connection factory because I want it to participate in all this stuff. And in the demo, all I do, it's a really simple demo. I send a JMS message, and then I do a database insert, and then I throw an exception. And then in another one, I do the database one first, and then I do the JMS message, and then I throw an exception. I do exactly what I told you not to do. I throw an exception to roll back the transaction, and I'll probably fix that before I send you the code. Because I don't want to give you bad ideas. And in both cases, it does the right thing. It rolls those both back, and then in the third example, everything succeeds. So pretty cool stuff. All right, so I alluded to this earlier. So when you say Grails, you create a domain class, right? And you say Grails generate controller or generate all domain class name, right? So if you say generate all, you get GSPs and a controller. If you say generate controller, you just get the controller. But so we'll look at the controller itself. So you know what it looks like, right? It's big and ugly. It's got all the CRUD stuff in there. But it's got methods for create, update, delete, right? And the database persistence is right there. The delete method actually deletes. That's really bad, right? Because what I just said was we shouldn't do any of that inside of the controllers. The controllers should be really dumb routers, right? So part of the problem is that it's kind of tricky to implement this, and I still haven't really kind of landed on where it's going to, what it's going to look like. But what you really want to do when you refactor this is you want to have a service method that does the work and is transactional, either automatically or with annotations or whatever. But it shouldn't be coupled in any way, ideally, to the HTTP layer. So it shouldn't have any awareness of params or request and response and any of that. It should be really independent. So you can call it from a controller, but you can also call it from anywhere. So you don't need to pass in this magic map. So what I need to do when I generate this class using the new approach is I need to look in the persistent properties of the domain class and then create a method signature that takes not a params map, but a string username, string first name, string last name, int age, boolean, whatever, and then calls all the setters and then does all that work, and then you can kind of clean that up. So that's going to be tricky to do and a little brittle, I'm assuming. So that's really why we haven't done it yet. Is that I don't know. It's kind of a weird thing. So. But scaffolding is now part of it's not part of Grails core anymore, it's a plugin. We yanked that out along with Tomcat and Hibernate and yanked a whole bunch of stuff out of core in 2.3. So the scaffolding plugin can kind of grow independently of Grails. So we will do that for the 2.3 time frame. So in the future, it'll do the right thing. For now, you should refactor your code because even if you only do one thing in a transaction, it might be the case that later on you do some extra stuff, or you might have some other, you might have some work inside of a filter, or there might be some other thing that's actually doing multiple steps. And if you really want them all, again, to be atomic, they should all succeed or they should all fail. So it's better to do it now than have to refactor it later when you realize that you've got, things aren't rolling back right and you're getting inconsistent data and things are messed up in your database because you allowed a bad practice to propagate throughout your code. So just be aware that we sort of, I think it's very natural when you say Grails generate controller. We generate that code. We're sort of telling you this is our best practice. This is what we think you should do, and that's actually not the case. All right, so if you want to learn more, I wrote a book. You should buy it, and if you already have a copy, you should buy another one. Give it to your mom for Christmas. And like I said, I'll put the slides up on SlideShare later today, and maybe on the plane I'll work on fixing my code and getting a blog post out there for the demos. So thank you. So we have time for a couple questions if anybody, you guys just fried from 3 days of intense Groovy and Grails. All right, thanks.
Great, thank you both. We have a break until 5:10, where Noam 10 will tell us something about searching for the Grail.